Guys, have you ever thought about building an AI on top of your data foundation? If you have ever thought about this idea, in this video I'm going to show you exactly how I built an AI or chatbot on top of my data foundation, where I can ask this AI any question about my data and I get exactly the correct answer without hallucination. Okay? So you are going to learn so much if you really invest the time and watch this video. I'm going to show you in a minute the demo that I built so we can ask AI any question about our data exactly. So the idea is this. The majority of organizations have their data foundation ready, right? And they are not able to enable AI on top of their data foundation. And in this video, I'm going to help you learn this skill, different tools to how to put all these tools together to build AI agents so they can help you answer questions about your data. We are going to learn so many different things. This project is built on GCP, where we are going to first build the data foundation. If you are new to data engineering, you are going to learn how to build the data foundation in the first place using different technologies, using Google Cloud, BigQuery, Google Cloud Storage, dbt for transformation, data warehousing, like building a data model, actually, real data model, and different things like using Terraform to build the infrastructure, using dbt for transformation, Google Cloud Storage for raw data layer, the raw layer, also the BigQuery for our data warehouse. On top of that, we are going to use agents. Like first one, we'll have a root agent, where this agent is the coordinator, where it can help us to assign tasks based on sub agents. So, and also we're going to have MCPs and RAG. Okay, if you are new to this, I highly recommend you watch this video. Just in a minute, I will present the demo, and then I will share with you the code and all of it, how it was built, and you can do exactly the same on top of your data foundation. And if you don't have a data foundation in the first place, this video also going to help you, or this project, to build the data foundation. So basically, this project is end to end, from the raw data, from the raw layer of your data into the consumers, into the last layer, which is the deployment, and where we have an AI product ready for us to ask it anything about our data. Hope you enjoy it. Let me know if you have any questions, and let's jump into the project. Let me explain it and let me show you the demo. So let's get started. Let me show you the product that we have built first. I deployed this AI product on Google Cloud Run as two Docker images. The first one is the front end and the back end. Of course, we are interested in the front end. You can click this link and we get access to our AI product. This beautiful UI that you see here, you ask your question, you get exactly the answer that you're looking for from our data foundation. There is no hallucination in this product. This is the important part, because that's what make these AI products trustworthy, right? We are actually querying the data. Sorry, we are asking this AI to answer from our data. We don't want any answers outside of that. This is very important, and I'm going to show you also in this demo. So I have the repository here, and let me ask AI a few questions. I listed them in the README file. So let's start with this. Before I put that one here, let me just say, how are you doing? So give me the answer. And the reason that I ask this simple question, I want to show you the agent. So I also build this UI to show us the agents, who is the agent that answer this question, because this project also using multi-agent. We have the root agent, and then I'm going to show you the architecture after that. We have multi or sub-agents that help us answer this question. For this particular question, as it is very easy, it's not related to our data at all. The root agent answered this. The enterprise operations agent is the coordinator or the root, yeah, that is going to distribute the work based on the question itself. So we build few agents, and we say when I'll show you also in the code that each agent is supposed to answer a specific question or a specific domain. Let's put it this way. And also for each agent has different tools, MCPs. So let's not dive into that right now, but let me start with this question. For example, the first one, put it here, and it might take some time for the first query, and then it will speed up a little bit. And yeah, actually it was good. It was not that, did not take that much time. But this is the exact answer that we have here, and the agents that help us answer these questions. The root one, of course, and the analytics agent. This one is for analysis, right? It's going to query the data from BigQuery, from our data foundation, where our data foundation is built in BigQuery, our data warehouse. And the tools that have been used is these tools that we built also, transfer to agent. Also, we have a tool called the BigQuery schema and BigQuery query. So this query or this tool, we build it to extract the schema of the table, so the other tool can build or can write a correct query, based on this. Right? We don't. Let's, for example, we might have order underscore date in our table. If we ask BigQuery without that context, it might say like order and then without underscore, like different style naming or different name at all, like order timestamp, maybe something like that. Yeah. So that's why when we provide the schema of our tables in BigQuery tool give us the exact query that actually runnable. And I can prove to you right now. I can ask it, can you provide the query? So I can run it, the query. That was fast. Let me try it out. Let's see if this is correct. I should get similar like this number, the total. So let me go into BigQuery. And it's runnable without any errors. That's a great thing. So I got 2,595,000. Where was it? 2,500,000. Yeah, it's the exact thing. Exact same thing. That's beautiful. So let's try a few other questions, because this project also, we build machine learning models to, for example, anomaly detection and also delivery, shipment, and all of that, because I'm not sure if I already mentioned that, but this project is related to retail, right? That means we have shipment, we have orders, we have customers, all of this. And the data was generated by Faker, like it's a package. It's a Python package. I also provide the script that you can generate this data. I generated few thousands of records. So let's ask another question about this. The revenue behavior. Show me the countries. Yeah, I can show you the behavior of this. Actually, I have a beautiful spot here. I don't know if you can see it, but oh no, I'm not actually sharing the. Let me see. Actually, it's very beautiful here. I have my drinks here. All good. But it's getting late. I think I need to go home. What happened? Wait a second. Oh yeah, I'll just put it this way. Let's go back. Yeah, let's continue. Let's see what happened to the agent. Happy days. It answered all these questions. So basically, it gave us the unusual revenue behavior for all countries that we have, and these are the unusual behaviors. Basically, I'm going to show you also the query how this happened, because we have a specific rules that we set there, machine learning models and all of this, to determine which revenue that consider like unusual, based on the historical revenue that we got for a few months. So let's go back into this. Let's ask this question: which shipments have the highest delivery delay risk? That means by this question, you can tell this question going to use a machine learning model to predict the deliveries or the shipment that's going to be delayed, right? So we also build a machine learning model in BigQuery with AutoML. Extremely simple. You don't need to be expert as a machine learning model, as a machine learning engineer. So you just use AutoML and build your model. So based on the historical data, the carriers with the highest delivery delay. So these are the ones that can be delayed. Okay, let's ask another question, which is, were there any pipeline failures or incidents last month? Let's see. Okay, that happened. See, resource exhausted. Sometimes you get this error because the credits and all of that. Just wait for some time and then ask it again. Looks like I will get some result, or the result here, hopefully. Let's see. I'm going to show you quickly the other repository after this. Yeah, it's very interesting, the architecture as well. Okay, while it's processing, let's go through the architecture part. This is the high-level architecture. We have the user here, as we were asking, the UI, the web UI, right? And then there's an API in the middle that take our questions and then ask the model, or basically give it to the agent, the coordinator. This agent has 3 sub-agents that we built. First one, we called it analytics agent, operations agent, the third one, knowledge agent. And these agents are using tools, or we call it a MCP tool layer, where for each agent we identify the tools that they need to use to answer the questions. For example, the analytics tool, like this agent, the analytics agent using the analytics tools here, which is BigQuery, BigQuery schema, and revenue anomalies. And for the other one, the operations agent, which is related to operations, that means something like related to risk, delivery outcomes, pipeline health, incidents. And for the other one, which is the knowledge agent, it going to use the knowledge search, which is coming from the RAG, like the data that we have as an organization. For example, we could provide like a data in files, or we could tell it to go into the database and read it, go to our Confluence page, any data related to the company itself. So it cannot hallucinate after this. The hallucination will be reduced drastically with this, because we have a knowledge base that we provide to the agent. Basically, this agent going to embed the knowledge, like that kind of, connect or extract the data that we provided, the business facts that we know, anything related to the organization, and then it's going to connect it with our query and ask the model. So the model has a context of our data, our business data, and also the database, access to the database itself. This combination prevent this model from hallucination and give us accurate answers to our business. So this makes this model trustworthy, and a lot of people will trust it because it gives us accurate results. I'm going to show you also if I'm going to ask this agent a few questions, like kind of this out of topic. Let's see how it's going to behave. So let's start that out and then come back here. Okay, we're still running of this. Let me ask the other question in the. Let's see if this. I think we already waited so long. Let's go, and I will just say from 2028. While it's running, hopefully we are not going to run into a resource exhausted error, but let's see. So this is the high-level architecture. You might wonder about the data itself, the data foundation, right? How we build it, what are the tools that we used. I think I mentioned them here in the workflow. So it's the same here. The user going to ask this question, and then we go into the API, then the coordinator agent, sub agents, then MCP tools, the data and knowledge sources. First, we have BigQuery datasets. We used dbt to transform the data and move data around from one stage to another. We used also BigQuery ML, machine learning models, to predict the delivery risk and all of that. I'm going to show you after that the models that we built. We also use RAG, and we use indexing to index these files so it can pick the exact things that we are looking for from files, right? This is for performance. So RAG indexing, like embedding. And also we have the internal documentation, incident histories as well. So these are the final answers that we get. And the deployment part, we did it using Docker images. So I built 2 Docker images, first one for front end and one for the back end, and then we deployed them into the Artifactory. Just to Google Cloud, we used a Cloud Run, so for front end and back end things. Like, images I can show you. Maybe I already showed you here, right? So these are the services. So this the container, this image AI, enterprise AI front end, and the back end. We deployed them here. So, and after that, of course, we used Vertex AI and all of that using BigQuery ML, AutoML to. So we are also used the models, the Gemini model. I can show you in the code as well. We can see it, the configuration part. We have so many files. Let me just collapse this. Then if we go to the macros, we have ML folder, anomaly detection. This about the models, right? But if we go into the agents, which is the most interesting thing, SRC, AI, and then we have the config file. And yeah, this is the agent that we used. And also we use this one just for performance because the embedding model. I tried to use Gemini, but it was a little bit I think it's very expensive because you are going to attach to it so many other documents, which requires a lot of tokens. And for that reason, I just use this mini LM, and I download that package and I used it locally. So this helps to reduce this getting that error, the resource exhausted error. Yeah, the models that we used are related to Gemini, yeah, Google Gemini. So let's go back here. So the architecture or the tables and all of that, the raw data sets, we created them using Terraform. Forgot to mention it here, but it's in the repository. We have a separated folder called Terraform, I guess. Where was it? This is the DBT folder. It's DBT folder, and this is the Terraform part where we created the tables, everything that we need. And yeah, that's this is about the infrastructure. This is the Docker file for the front end, sorry, for the back end. And for the front end, it's here. We put a Docker file, this is for the front end. So let's go back here and continue our architecture. Yeah, I think you got the idea about the overall picture about this project. If I go back here and into the README file, and then this is how it works. First, we generated the data. BigQuery, we use dbt to build the data foundation. Also, we build machine learning models. I forgot to mention or to show you how we build these machine learning models. We used dbt, actually used macros to create this machine learning code. As mentioned, used auto ML in BigQuery, just by writing queries and creating models. For example, you can basically, this one already predicting, and this one, let's see, where was it? I think maybe this one. Yeah, this is already evaluating. And this is the training part where we create the model. So create or replace model, give it a name, and then this are the parameters that we pass to the model, and then give it the query, which is the data itself, like kind of the data that we want to train this model. So after training the model, then we test it with the percentage of the data, and then start predicting and calling the model, give it the data, and then get the response out of the model. So we generated the code here in a macro, and then we can easily run this macro in dbt. If you are familiar with dbt, you should know these macros and all of this. So I think it's very simple. So I put them here so we can just trigger the macro or call this macro, and then the training or the evaluation part can happen easily. I think it's getting darker here, but let's wrap it up. I think yeah, we're already done. But this is the BigQuery ML models, and then we have the RAG. Quickly, I'll show you the RAG. So these macros, let's go out of the dbt. So we have the documentation, we have the RAG here, enterprise AI retail dataset. For example, we have MD file, and also we have JSON files, to just give them the context about our business, the business metrics, for example, net revenue, average, all of these things. So we want to prevent hallucination, something like this, incident runbook, all of that. So of course it's not that it's not a lot. It's not the size of this. Most of the time it's huge, right, for in the real world. But this kind of to show you how it works. First we have RAGs. We have many other things like the MCPs as well. I'm going to show you this. before that, this is the generator file that generated the data. You can use it to generate the data as well. So before, yeah, I think we are good here. The last thing is the MCPs, and we have two parts to cover, and then we are done for this video. So the second part, which is here, the MCP tools. Let me show you the MCP tools that we have. Actually, I built this 4 days ago. Can't tell. 4 days ago, and I was extremely busy. I did not really get the chance to record the video. My plan was to record the video 4 days ago, but that did not happen. Now I already forgot where are the files. But for the MCP things, yeah, this is the AI here, and then I put this AI things, all of it, like API, Gemini, MCP, RAG, all other tools that I used under this folder, under the AI folder. Yeah. So we have this is the MCP, and this is where it can be very interesting. So to create a tool, very easy, just say MCP. We use this fast MCP, and this is the tool that we have. For example, read only BigQuery analytics. This is one tool. We call it BigQuery query, and then we call this function and give it the query. So if you go back, if you go into this query, so it do a magic here and then give us the query. We also have few instruction here. We don't really want to dive into the code itself, but this is how we structure the tools in higher level. This tool for BigQuery to get the query itself. This one to get the schema of the BigQuery tables that we have in BigQuery. And where we use the, in BigQuery, you be able to extract the schema of all the tables that are present in a specific data set. So this is very helpful. And we also have revenue anomalies, where we get the data from ML, from machine learning model, give it few things, and then like we run the ML predict, something like that, yeah. And we have also delivery risk, where we get shipment with the highest predicted delay risk. So we give it some parameters like the date, end date, and all of that, and then we get the answer. We also have the tool of knowledge search, where we use our documents to check the data or the internal data that we have as an organization. And also we have the pipeline health, where we have a data of our pipelines. And there's many horses here. Beautiful. Okay. Anyway, I can't show you because it's there is I'm in the forest. We're not really clear. So sorry guys. But where was I? Yeah, I think these are the MCP tools, right? And then what do we have more? We have that. Yeah, this is MCP. We have the, of course, agents. This is the most important thing. Why we forget this? Agents. We go into the agents, and this is the first agent is the coordinator, where we give it the instruction and give it a definition about itself, and like just instruction, what to do, what not to do, and all of that. So this, we called it, this is the root agent. Its name is the enterprise operations agent. And then the second, or the sub agent, is analytics agent. And we told this agent to use this tool. And also we give it an instruction, like about its job. And the model that we are using, this Gemini. The second agent is, we are using this model as well. We are giving it a description, instructions, and the tool that it has to use. And the last agent is the operations agent, the same thing. We have it, we are using this model, this is the name, these are the tools that we asked this agent to use. So and also identify it here in the MCP tool set. For example, for the analytics tool, we identify these analytics tools. It has to use these functions or filters or tools that are we already built using the MCP. So we have 3 that will be under this, yeah. And this one is already in the agent. If you see here, this is, for example, the analytics agent. Where was it? Here. This is the analytics agent, right? We told it to use this analytics tools. And if you go into the analytics tools itself in the MCP configuration, we have these functions that are going to call. Like first, to because it's for analytics, that means we'll need to create a query. We'll need to know the schema about the tables, and also for the revenue anomalies. So we can use that one as well. So it can be comprehensive and give us the correct answer. And likewise, the other things as well, it was built the same way. For example, for the operations, we have many tools here that we need to use, because we could, the user could ask us about the health of our pipelines, incidents, etc. For the knowledge, we don't have that much. We just have our data documents where they are present here. Yeah, this is the I think that's the main thing that I want to mention in this video. Let's show it here. After that, we just use Fast API and some other packages that to build the UI. And the deployment was in Docker, like sorry, on Google Cloud Run, using Docker images of that. I think I already mentioned that, right? So the Docker image for this is for the back end, and this the one that is for the front end is under the front end folder, and we have a Docker here. Sorry, not this one. Should be somewhere here. Yeah, this one is a Docker image for the front end, and deployed it into Google Cloud Run. That's how you see it here. Sorry guys, we are running out of resources, but I think now if I can ask it again, I think I should have done it earlier. Okay. Before this video, I was trying it out myself. It was working perfect. But I think I already exhausted the resources before recording this video, which was not a good idea. I should have started the video earlier. But anyway, I think you got the idea. That's the important part. And this is the high architecture. Also, we have this diagram where we have the user, we have the like the UI that you see right now. Then the middle we have API, where we call the root agent. The root agent use different agents to answer, and then these agents using MCP servers, MCP tools. For example, this agent could be using like the RAG itself, the ML, BigQuery ML that we already built, and BigQuery dbt marts that we built also in BigQuery. We use dbt to transform the data from the raw into the into different layers, like marts and machine learning. So in the beginning, of course, we got the data into Google Cloud Storage, and from there we export them into our raw data. We have few scripts there also. The script, all of that, everything is included here. You can follow the instruction here how to do it, and you will do exactly the same. For example, for the machine learning things, you need to run these commands to generate to run the machine learning themselves, like to build the models, train them, all of that. For this, for the anomaly detection, for delivery delays, the agent architecture, you can build that as well. These are the instruction. So from here, for example, what do you need? The prerequisites. You need these tools, and you clone the repository, put the link here, I should put the link here for the repository. You can then start from your repository. Before you fork this repository, you can fork it and then use it your own if you want. You need to create virtual environment, install the requirements of this. We use some other things. We use Google Cloud in this project, and this is for Terraform to build the tables. So this is it's a production grade project, I would consider it, because we used all the modern data engineering tools, machine learning tools, AI tools, all of that. So this could be extremely helpful for you as a beginner if you're really serious to learn about data engineering, machine learning, AI, and this modern technologies like MCPs, RAG, and all of that. You just study them. At least when you get the idea about the overall picture, you can maybe dive for each part and then study them alone and spend some time there. I really, really hope that was beneficial and that was informative for you. And I think I need to wrap it up and then head home. Not sure if you still can't see me, but yeah, it's getting darker here. It's a beautiful part, beautiful forest. All right. That's it. Thank you for watching, and I will see you in the next video. Take care, guys.